Good morning, dear students. Today I'm going to discuss about rules for finding complementary function. Well, it is most important for higher order differential equations. In each and every problem, without complementary function, we have no solution. So, should know about this one. Just simply, if you remember four rules of complementary function, what are the four rules? That is, we can discuss now. Here, first complementary function. When we can find complementary function? Here, complementary function means that is for homogeneous differential equation we can find. And for non-homogeneous differential equation also we should find complementary function. The non-homogeneous equation means that is of the form f of d into y. That one is equal to q of x. Here, for this general solution means complementary function plus particular integral. How to find the particular integral, that is we can discuss in next classes. Here first we should know complementary function general procedure. Here if the given equation is homogeneous linear differential equation is of the form like this. F of d into y, that one is equal to 0. Then here, what is f of d? Here I am taking f of d is nth order differential equation. That is a naught into d power n, a1 into d power n minus 1 plus a2 into d power n minus 2 plus 1, n minus 1 into d plus a. What is b here? D means that is the differential operator. Differential operator. Here d means d by dx. D square means that is d square y by d square by dx square. Okay. Here similarly d power n means d power n by capital D power n is equal to d small d power n by d power d into x power n. D power n by d into x power n. Here it is the capital D power n operator. Okay. Here how to find complementary function? Here f of d replace d by n. That is the algebraic equation. Okay, algebraic equation that is said to be auxiliary equation. Here replace d by n. Here for this we need to find the roots. Here it is a nth degree equation. It is the nth degree equation. Nth degree equation in algebra. Okay, algebraic equation of nth degree. Then for nth degree means how many roots we can get? N roots we can get. Here in these n roots, here different types we may get. Here first I am taking roots are real and distinct. These n roots are real and distinct only. Real and distinct means here all are different roots and real. Then what is the general solution? Here general solution is given by like this. C1 into here these are M1, M2, M3, Mn so on Mn are real and distinct. That is why C1 then general solution is C1 into e power M1x, C2 into e power M2x, C3 into e power M3x, so on Cn into e power Mnx. It is the complementary function. It is said to be general solution of homogeneous differential equation, or if non-homogeneous means it is a complementary function. Non-homogeneous means equation is of the form f of d into y, that one is equal to q of x. For this you can get two solutions. First solution is this one, complementary function. It is said to be complementary function. Next, equal to some q of x is there. For that, how to find the solution, that we can discuss. Here, next, here it is the general solution when the roots are real and distinct, right? Next, for example, simple example I am taking here, 1, 2, 3, 4 are the real and distinct roots. 1, 2, 3, 4 are the real and distinct roots. Then general solution is given by like this, that is y is equal to C1 into 1 into x. 1 into C2 into e power 2 into x, C3 into e power 3 into x, C4 into e power 4 into x, like this. It is a general solution when roots are real and distinct. Then here, next case 2. Case 2 is roots are repeated. Here, roots are real and repeated roots. Real and repeated means what? Now, here in this, I am taking two cases. In case 2, sub cases I am taking if two roots are real and equal. Two roots are real and equal. And remaining roots are real and distinct. Real and distinct. Then that is like this. M1, M1. These two are both are same. M1 and M1 both are same. Remaining are real and distinct. Here first two roots only repeated. Then what is the solution? Here that is then solution is y is equal to here C1 into C1 plus C2 into x. C1 plus C2 into x e power M1x. E power M1x. That is the for repeated roots, it is the solution. Here, if repeated twice, it is a solution. Thrice, what is the solution? We can discuss next. Here, remaining roots are real and distinct. That means C3 into E4 M3x, C4 into E4 M4x, so on Cn into E4 M Next, if three roots are real and distinct, real and equal, three roots are real and equal means here in previous part you taken C1 plus C2 and C2x plus into e power M1x. Here, three roots are repeated means C1 plus C2x plus C3x square. C3x square e power M1x. Remaining all are the real and distinct. Then C4, three are completed, right? Then C4, E4, E4, M4x, C5, E4, M5x, En, E4, Mnx. These are the, it is the, it is the general solution when three roots are repeated and remaining are real and distinct. Then, if for example, I am taking here example, two roots are repeated, means C1 plus C2x into e power x, e power 1 into x, plus C3 e power 2x, C4 e power 3x. It is the general solution when two roots are repeated, remaining are the distinct. For example, three roots are repeated. Three roots are repeated means C1. Here I am taking three roots means that is 4, 4, 4. It is repeated how many times? Three times. Remaining all are the real and distinct. Here 10 C1 plus C2x plus C3x square into e power 4x. Okay. Here C4, C5, C6 into e power 5x, e power 6, so on. It is a real and distinct, that is, it is a repeated one. Okay. Yeah. These are the general solutions when roots are real and distinct, roots are real and equal. Okay. The next one is imaginary roots. Imaginary roots. Sometimes we may get imaginary roots also. Here, in that case, imaginary roots means here we may get like this. That is a plus or minus ib. A plus or minus imaginary. Here, if we got imaginary means in that case, 100% we may get paid only. Paid means with positive and with a negative. That is a plus ib, a minus ib. Like this only we can get. Okay. Here these are said to be imaginary roots. That is here two roots are imaginary. Remaining all are the rest of roots are real and distinct only. In that case, here we may get it is the general solution. It is the solution of the roots. Here e power ax. What is the real part here? A. E power ax we should write outside. Then c1 cos dx plus c2 sin dx. It is the solution when roots are imaginary. Remaining roots are real and distinct. Then C3 e power m3x, C3 e power m3x, C4 e power m4x plus so on Cn e power mnx, Cn e power mnx. It is the General solution when two roots are imaginary, remaining are real and distinct. Here, not. Next one is sometimes we may get repeated roots in uh, imaginary also. Here, in that case, here imaginary roots are equal. Imaginary roots are two pairs of imaginary roots are equal. Then that is we make it like this. A plus or minus IB, A plus or minus IB. These two pairs are same. Here how many roots are there? Totally four roots are there in this. In this plus or minus with plus or minus, in this with plus or minus means four roots are there. Remaining rest of the roots are the real and distinct. Then here what is the general solution? E power x. It is a real part for four roots. It is a real part. E power ax into here repeated. Repeated means same as real and distinct. Here C1 cos C1 plus C2 x into cos bx. Here we can get additionally cos bx. There C1 plus C2x into e power, for example, real root is m1x means in that case m1x we can write. But here C1 plus C2x into cos dx, C3 plus C4x into sin dx. We should write this one. Okay, here it is the solution when roots are real and, roots are imaginary and equal. Imaginary and equal. Here C pi e power m pi x plus C6 e power m6x 1 Cn e power mnx. Here remaining roots are all are the real and distinct. Then it is a solution. For example, here I am taking some simple examples for you. Here, for example, 2 plus or minus 3i. 2 plus or minus 3i means these are the roots. Okay, two roots. Okay, two pair you can imaginary means always we can get pair only. Then solution is this one. That is y is equal to e power 2x into c1 cos 3x plus c2 sin 3x. It is the solution when roots are imaginary. If roots are repeated, means two pairs are same, right? Then here, what is the solution? Real part is equal to x, but you can write that is outside. C1 plus C2x plus into cos 3x plus C3 plus C4x into sin 3x. Like this, we should write the general solution when roots are imaginary and repeated. Okay. Yeah, then for example, sometimes we may get roots are like this only. Okay, without imaginary part, we can get like this. Only without real part, we may get like this. That is only imaginary part we may get. Only imaginary part means here real part is 0. That means e power 0 means that is 1. No need to write this one. E power 0, no need here. E power 0 means that is 1, you know. Here C1 cos 4x plus C2 sin 4x. That is right. That is the general solution when roots are only imaginary. C1 cos 4x plus C2 sin 4x. Similarly, sometimes we may get repeated roots. Repeated roots means plus or minus 3i, plus or minus 3i repeated twice, paid repeated twice. Then it is the general solution. What is that one? C1 plus C2x into cos 3x plus C3 plus C4x into sin 3x. It is the general solution when two pairs are repeated. That is only imaginary. Okay, that is without real part. Okay, here it is these are the total four formulas. These are the total four formulas for uh, rules for finding complementary function. I think you understood. Thank you.